This is the component 3 mock, and it's mock number 4 that we've prepared for you. And a villi, so we're talking about nutrition and digestion and so on. And you should recognise a villus and some of the various cells and structures. And a typical sort of question with X, Y's and Z's and A's and B's and things like that. Give a name for structures A, B and C. Right. A. These are, plenty of them. These are our goblet cells. Even though they don't particularly look like goblets on this diagram, if you look in very carefully, you see there is a slight bottom to them. But it says mucus secretion, so it's got to be them, hasn't it? Goblet cells. B. I've just been on Wikipedia and found out what B is. B is Paneth cells, and those secrete various enzymes, mainly sort of antimicrobial sort of enzymes. That's not actually on our spec, so we'll forgive you that one. So don't worry about that one. The rest of the question is good. Anything that comes up like that on the exam, the examiners at their meeting usually complain, and it gets the treatment it deserves. Move quickly on to C, Brunner's glands. So these, again, this alkaline bit of it should have given it away. So even if you don't recognise where they are or what they are from the diagram, the fact that it's alkaline, that can only be our Brunner's glands, and that is on the spec. So you should be fine with that. So goblet cells, I better put them around, so Paneth cells and Brunner's gland. Or you could probably go away with cells there as well. Back on easier territory now. Two functions of mucus. Well, this is a small intestine and it's received lots of enzymes from the pancreatic juice that are digesting lots of organic molecules. Well, this lining itself is made out of organic molecules, and protein. So the enzymes would start digesting the lining of the wall. But the mucus which is kind of on this lining, will protect that wall from digesting itself, or self-digestion, or autolysis it's called. So protects the gut wall from, I'll just write self-digestion. But also in various places in this system there might be acids or alkalis there, so it protects it from those as well. And we've got alkaline mucus. Well, that must be alkaline for a reason. Where has all this kind of half-digested food come from? Well, it's come from the stomach, which has got a very acidic pH. So the alkaline mucus, it told you the answer up there, is to neutralise the acid from the stomach. So neutralise the acid from the stomach. All the things it does, well, you've got food rolling past and it might bash into the lining and damage it, but actually this lubricates it, kind of oils the path for food through the system as well, so it provides lubrication for the gut lining. Lubrication for the gut lining as the contents are moved through. You only needed 2 of those to get the marks. Apart from its length, so the small intestine being a few meters long. State 2 other ways in which the surface of the small intestine surface area of the small intestine is increased. But if you look at this diagram, the diagrams are always trying to help you in these. You can see this. The length is on this piece of paper a few centimeters, but if you actually measured the length of this lining here, then it would be a lot more than 20 centimeters, a lot more than a few centimeters. So these folds, and the villi and folds, that's increasing the surface area. So we can just put it's folded. And we've got lots of these villi, which would do the same thing. So lots of villi, which is the plural of villus. And now we can actually talk about the thing you probably mentioned, thinking of was this brush border or microvilli, which you can't really see on this diagram. So you can say microvilli increase the surface area. So hopefully you definitely got 2 of those. That's not a difficult question, hopefully. Identify structures X and Y and state what is absorbed. So what is absorbed? So something must be absorbed. So we need to identify them. So there's 4 marks here. So probably there's 1 mark for identifying and 1 mark for stating what is absorbed. X comes from one side, goes up and across the villus and then disappears off the other side. And Y is just this kind of big blob in the middle, connected to some sort of general system, but it doesn't seem to have like an inner and out. So the thinner one, we're going to go for capillaries, so blood capillaries. And the other structure, one in the centre, it's always in the middle when you see these diagrams in books and in your notes. And that is our lacteal. So lacteal. We could also say lymph duct or lymph vessel or that sort of thing as well, but lacteal is the usual label. And so functions, capillaries, well, what are they doing? It's saying what is absorbed. So what does that actually mean? What is absorbed? So stuff goes from the lumen of the gut across through up in the microvilli and into the body essentially, and they get taken up into capillaries. So what moves across and then goes into the blood? Generally things that dissolve in water. So the end products of digestion that are water soluble. So water soluble end products of digestion. And you could give an example here. You could possibly say an obvious example, glucose, because that's the one you've studied with the microvilli and co-transport, or perhaps amino acids, something like that. So really kind of small end products of digestion. You can't have things like maltose or starch or anything like that. In the lacteal, it's other end products of digestion, but things that dissolve in fats really, are lipid soluble. So fat soluble materials, things, an example there might be fatty acids, glycerol, those sorts of things. So reasonably straightforward. 12 marks, 11 marks if we ignore, or 10 marks possibly if we ignore the Paneth cells there. But you don't need 100% to get an A star, so you won't need those, I'm sure.